Welcome, friends. I'm so glad you're here. Whether you're drifting towards sleep, unwinding after a long day, or simply looking for a quiet companion, you've found the right place. Before we begin, I'd love to know, where in the world are you listening from? Perhaps you're wrapped in a blanket, sitting by a softly lit window, or resting somewhere under an open sky. Wherever you are, I hope you're warm, comfortable, and ready to wander with me into the strange and silent landscapes where circles mark the earth for reasons no one fully understands. If you find peace or curiosity in these gentle stories, please consider liking the video, subscribing to the channel, or sharing it with someone who might need a moment of stillness too. And to those who've already joined along, thank you. The story begins in the pale light of an early morning, when the earth is still cool and the air carries the faint smell of dust and stone. Spread out below, the surface is a muted palette of browns and greys, marked here and there by brush and scattered rock. Then, almost imperceptibly, a perfect roundness begins to emerge from the randomness of the land. Its edge is not sharp, but softened, a slope falling gently inward. The curve so precise, it feels as though a compass has drawn it in soil the size of a village. Scientists call these features circular depressions. They appear across continents, in deserts, grasslands, tundra, and volcanic plains. Many are wide enough to hold small towns. Others could be mistaken for ponds if filled with rainwater. The remarkable thing is not just their shape, but their isolation. Each one stands apart, alone in its surroundings, as though placed deliberately. From above, satellites capture them as clean, dark rings against pale terrain. Aerial surveys have traced hundreds of such formations, some linked to known geological processes, others stubbornly resisting classification. Erosion alone rarely creates such uniformity. There are salt pans and sinkholes, yes, but these circles often lack the telltale collapse marks or the mineral crusts that hint at evaporation. Instead, they sit in patient stillness, their forms nearly unchanged for centuries. In the field, the impression is even stranger. Standing at the rim, a visitor sees only the slow, inward dip, a concave stage for wind-blown grass or patches of bare ground. Sometimes, a ring of slightly taller vegetation lines the edge, nourished by subtle changes in soil moisture. A geologist might note how these rims collect runoff from seasonal rains, concentrating nutrients and sustaining plant life differently than the surrounding plain. One known fact offers a starting point. Circular ground features can form from underground dissolution, when rock layers like limestone are slowly eaten away by water, leaving voids that eventually cause the surface to sag. This process, called karst subsidence, is well documented. But here, the evidence is incomplete. Many circles lie far from soluble bedrock, on plateaus of basalt or compacted clay. The usual mechanism doesn't fit. A lesser-known observation, published quietly in a regional survey, describes how some of these circles appear aligned along invisible paths, faint ridges or depressions in the bedrock, as if following an ancient underground seam. The patterns suggest a connection, though no one has mapped it in full. The mystery deepens because there is no consensus on their age. Some have clearly accumulated centuries of soil and plant growth, their curves softened by wind and rain. Others cut crisply into the ground, their edges still steep, implying a much more recent origin. One hypothesis, spoken softly among certain field teams, is that these are the remnants of forgotten human activity, large-scale structures, perhaps ceremonial in nature, whose true shapes can only be appreciated from the air. The idea remains unproven. Excavations are rare, and many sites are so remote that no formal studies have been attempted at all. From above, they resemble quiet punctuation marks scattered across the vast page of the earth. Each one a small pause in the landscape's long, uninterrupted sentences. They invite the eye to linger, the mind to drift, and the body to rest in the stillness of their form. Patient, circular, and endlessly waiting. The light is low on the step, sliding along the grass as if it prefers to touch rather than illuminate. At this hour, the plains of Central Asia look almost metallic, a brushed surface of feathergrass and dust where elevation changes by mere handspans. Then the angle deepens, and the land begins to speak in shadow. Rings appear faint at first, then steadier soft halos that the midday glare erases, but dawn and dusk restore with patient precision. From the air, pilots and satellites alike register the same quiet geometry. Low solar elevation exaggerates micro-relief. Even a few centimeters of rise or fall cast a pencil-thin darkness. In remote sensing terms, raking light increases contrast and pushes subtle forms above the threshold of detection. It is a simple fact of physics. The longer the shadow, the louder the whisper of the ground. What seemed like uniform prairie reveals repeated circles, some nested like ripples, others solitary as coins pressed into clay. Aerial archaeologists have a name for these revelations: shadow marks. They differ from crop marks that depend on plant vigor and soil moisture. Here, the mark is the relief itself. On flyovers, the rings close and open as the aircraft banks, their clarity changing with every degree of sun angle. Photographs gathered over seasons confirm their persistence. Many occur in clusters, arranged as if along old lines of travel or around subtle divides in the drainage. Yet there is no road, no wall, no foundation to anchor certain interpretation. A lesser-known detail drifts at ground level. In late autumn, frost feathers, a lace of needle ice, thicken along the outer lip of some rings. The microslope cools the air a trace more. Vapor condenses, crystals rise, and morning sun ignites them for a minute before they sink back into water. Field notes mention this in passing, a margin observation beside transect measurements. It carries no grand conclusion, only a tactile sense that the circle slightly edits wind, temperature, and light. One accepted process explains part of the scene. Throughout mid-latitudes, once touched by Pleistocene, cold, periglacial ground can organize itself into patterns, polygons, stripes, and sometimes rings through freeze-thaw cycles and the sorting of stones. When the ancient climate softened, these patterns remained as ghost topography. If the steppe holds relict periglacial features, the circles would be the long memory of ice in a place that no longer freezes so deep. The geometry, visible only when the sun writes with a slant pen, becomes a ledger of an older weather. Yet the mystery persists because not all rings fit that inheritance. Some lie where permafrost is absent in modern records and unlikely in reconstructions. Others are too large or too regular to match textbook patterned ground. A few contain shallow ditches, interrupted at consistent intervals, like entrances or causeways cut and then worn to the same gentle grade as the rim. Around them, the grass changes height and hue in narrow bands, hinting at buried contrasts in soil grain or compaction. One academic, uncertain hypothesis proposes that several of these circles are pingo scars, the collapsed remains of ice-cored hills that rose when groundwater froze under pressure and later melted, leaving round basins. Pingo scars are well documented in Arctic terrains. Scattered studies suggest relicts can linger far beyond the zone of modern permafrost. The steppe examples would be outliers, demanding precise dating to test. Optically stimulated luminescence could estimate when sediments last saw sunlight. Radiocarbon from buried plant matter could frame a bracket. Both are difficult when depths are shallow and disturbance unknown. Another line of thought, more archaeological than geomorphological, sees ring ditches traces of earthen enclosures, long flattened by weather and hoof. Across Eurasia, ancient communities ringed spaces with shallow excavations for ceremony, burial, or stock. Their forms later detected by shadow or growth. In Central Asia, kurgans and ringed precincts endure as low crowns and collars on the grassland. From above, some steppe circles share that restraint of proportion, with breaks that could be entrances oriented to a horizon event. If true, the rings would be human work, their silence cultural rather than glacial. Between these possibilities, the land keeps its voice low. Survey teams walk transects at dawn, tripods planted where the gradient merely hints. They measure with differential GPS, stack profiles, and watch the day erase what morning revealed. A drone hums a patient grid. Later, photogrammetry stitches a digital surface where a few centimeters matter. The maps confirm roundness, record diameters, and quantify slopes that the eye already knows. The data are crisp. The meaning remains soft. A smaller, poetic note threads the observations. Larks favor the rims. In spring, they drop into the lee of the curve and lift again, using the slight shelter to stage a vertical song. Their presence says little about origin, but much about continuity. The ring offers a momentary windbreak on an otherwise even plain. A creature measures the land with its own breath and chooses this edge as a perch. The behavioral map overlays the geological one, both unassuming, both exact. Not all circles persist through the year. Some appear only after rare rains, when damp soils darken in a curve and dry more slowly along a shallow ditch. There is a sense of timed handwriting, the ring written in moisture, legible for an hour, gone by noon. Spectral indices from satellite passes pick up the change. Analysts tag it as a transient anomaly and file it beside the more durable forms. The archive grows, each entry a small testimony to shape without explanation. At the far edge of the discussion sits a quieter, peripheral speculation. In local stories gathered during fuel stops and tea, lights sometimes rest on the horizon and leave nothing but a circle of pressed grass by morning. The accounts are not evidence, and they do not enter formal reports, but they live around the fieldwork like distant weather. The academic conversation does not rely on them. Still, as with many landscapes, the catalogue of shapes collects rumours the way a rim collects dew. What can be said with care is this: the steppe stores histories in low relief. Some rings likely record frozen ground undoing itself. Some may trace the limits of communal spaces. Some could be shallow deflation hollows, where wind found a weakness and patiently worked in circles. Each mechanism leaves a slightly different signature edge sharpness, internal texture, relation to slope and drainage. The signatures overlap just enough to resist a single, confident label. When evening returns, the light repeats the morning lesson in reverse. Shadows lengthen, circles darken, and the plane accepts its ornaments again. The airy tools of the present multispectral bands, angle-aware composites, polarization tricks continue to improve the view. But improvement is not the same as closure. The rings remain what they are, careful openings in a vastness, visible only when the sun chooses its low handwriting across a continent of grass. In the inland deserts where sand carries the memory of wind, roundness rises not as a hole but as a wall. The circle stands knee-high, sometimes chest-high, a low ring of stones pulled from the surrounding ground and settled into a careful line. In morning light, each block throws a short shadow inward, so the empty center looks darker than the plane. From above, the structure reads as a drawn circumference, an outline more than an object, its purpose withheld by simplicity. Dry stone endures where rain is rare and plants are thin. Without roots to pry and little water to lift and topple, a wall laid once can remain for centuries with only minor slumps and gaps. Across basalt fields and gravel plateaus in arid belts, circles persist like punctuation, their surfaces slowly filmed with desert varnish. The accepted process is patient. Dust lands on rock, a fine skin of moisture forms, microbes help fix iron and manganese, and a thin glaze darkens the stone by micrometers each year. Over long spans that glaze can be read for relative age, a quiet ledger of exposure in places without trees or timbers to date. Walkers meet these rings without announcement. One appears past a dune toe, another beyond a hummock, each large enough to surround a small herd or a gathering of people. Inside, the floor lies slightly cleaner of stones, as if hands once cleared the center. Sometimes there is a break in the rim, a narrow gap where feet or hooves might pass. On other circles, 3 or 4 short lines run inward like spokes, ending before the middle, a geometry that hints without speaking. A lesser-known detail gleams on certain stones in the first hour after sunrise. Beads of dew condense on varnished faces and linger longer than on pale, raw rock. The film thickens just enough to turn darker stones into tiny lenses. When the sun lifts, they sparkle across the ring for a minute before vanishing. Field notes from unhurried mornings describe this as a minor miracle of humidity, a microclimate woven by darkness and emissivity, seen only by those who arrive before heat. Archaeology accepts that rings of piled stone can be the most durable traces of pastoral life. Where timber is scarce and earth is hard, people make pens, windbreaks, and shelters with what lies at hand. Low enclosures concentrate warmth at night and slow the wind. They also collect drift sand that buries lower courses until the wall becomes half dune, half architecture. Elsewhere, circles mark graves or enclose cairns, their function commemorative rather than practical. The fact is simple and firm. In deserts, stone keeps decisions that cloth and wood forget, yet the catalogue grows faster than meaning. Many rings sit far from springs or seasonal floodplains. Some cluster on open uplands where neither pasturage nor travel routes seem favoured. Excavations are sparse. Ceramics and bones, when present at all, are thin and wind-scattered. A few rings appear to predate the nearest surface artifacts by unknown spans. Others look recent by their crispness, yet yield nothing that fixes a year. The uncertainty is not dramatic. It is stubborn and ordinary, a missing label in a landscape that preserves forms better than stories. Geomorphology offers an alternative voice. Wind sorts landscapes by size and weight, winnowing fine particles and leaving a desert pavement of pebbles. Under persistent gusts that curl around an obstacle, a shrub long gone, a buried boulder stones can organize in low arcs and rings. The mechanism is accepted where vegetation once created nebkas, small dunes with a plant at the core. When the plant dies and the dune migrates, a stony halo can remain. Some circular stone belts are therefore natural residues, their order the product of years of directional wind, not hands. A quiet mystery remains in circles that refuse both stories. These are the rings on bare lava where no sand accumulates, the rings whose stones are too large to have blown into place. The rings with internal spokes laid as if to divide space that no longer holds a task. Remote sensing sometimes shows alignments among certain groups, beadwork that points roughly toward persistent stars at rising or toward breaks in the horizon where the sun swings wide at solstice. The lines are not perfect. Geology presses, paths wander, and later hands repurpose old stones. Still, the suggestion lingers like a faint track under fresh dust. One academic, uncertain hypothesis proposes that some rings function as horizon instruments, low, human-scale devices for teaching cardinal points and seasonal extremes by sighting across paired stones. The idea borrows from known practices in pastoral astronomy, where navigation and calendar-keeping matter to movement and ritual. It neither insists on observatory precision nor claims a single culture. It simply suggests that, in many times, small communities can set circles to hold the sky still enough for learning. The evidence is circumstantial breaks that face sunrise, paired uprights on a rim, a repeated diameter suited to pacing, but it remains testable in careful surveys of orientation and line of sight. Science, in its patient register, gathers what it can. Desert varnish speaks of years, classed imbrication records prevailing winds. The absence of lichen suggests aridity longer than memory. Where excavation is allowed, shallow trenches sometimes reveal that lower courses are as regular as the top ones, implying intentional placement from the start rather than chance accumulation. In a few rings, hearth ash stains the center. In others, quartz flakes lie along the inner edge, where tool-making once produced bright shards, now dulled by grit. These are modest findings, but in deserts, modest evidence carries weight. At sunset, a different, practical poetry returns. Lizards use the ring as a thermal clock. They surface onto sun-warmed stones, then slip beneath the lowest gaps as the heat drains, pacing evening by inches of shelter. Night winds comb the rim and leave faint fans of dust on the lee side. By morning, the fans are erased and written again. In this daily script, the circle behaves like a gentle machine, turning light and air into predictable niches. The larger question of origin remains untouched by the habit, but the habit shows why stones continue to matter to animals, to temperature, to the small physics of living. No figure stands at the center. The ring itself keeps the roll. It gathers gusts and spills them, catches dew and lets it go, absorbs sunlight and releases it as ground glow, like a planetary exhale contained in waist-high stone. Stars wheel, and the circle neither answers nor asks. It keeps a center clear and a perimeter quiet, and in keeping them, it survives. By the time the sky loses color, the shadows have folded back into the wall. The interior looks level and anonymous again. In maps and in memory, the ring remains a small exactness on a vast field, a unit of measure without numbers. It belongs to stone, to dust, to light, to the long patience of surfaces facing the sky. What it once organized animals, people, seasons, wind does not speak aloud. The circle stands where the middle of nowhere accepts a form and agrees to keep it. Far from any river valley, on dry plateaus, where cloud shadows travel farther than streams, blue circles rest in the earth as if the land has gathered its breath and held it. The pools sit quietly on uplands of granite and basalt, on clay mesas and old lava, with no visible inlets and no outlet to explain their patience. Around them, the ground is pale and granular, sun-whitened, wind-combed. Within, water thickens the sky to a darker tone and keeps a low, steady mirror for days, months, sometimes years. The accepted processes begin small. On bare rock, rain lingers in tiny hollows. Chemical weathering works at the wet rim. Salt crystallizes during dry spells and pry grains loose. Wind scoops away what breaks free. Over centuries, a shallow dimple deepens into a basin. Geomorphologists call these weathering pits, namas, or rock holes, self-feeding cavities that collect the very water that enlarges them. Where a thin soil skin forms, another mechanism joins. An impervious clay or calcrete layer seals the bottom, forcing rainfall to stay rather than seep, and a perched pond forms in a landscape that otherwise refuses to hold it. There is a lesser-known, intimate detail in the way these bowls wake after rare storms. The first hour brings a quiet, glassy film. Then life writes itself in small cursive. Whirligig beetles inscribe tight ovals on the surface. Fairy shrimp uncurl from durable eggs, cysts that have waited in dust for a decade, and swim upside down beneath the light. Algae bloom in threads no wider than breath. Field notes speak of a faint mineral sweetness at the rim after the first hot day, and the way dragonflies learn the pool's geometry by flying it, tracing the circle with a precision that seems borrowed from the basin itself. Hydrology supplies firm ground. Many upland pools are fed not by streams, but by the slow recharge of a perched aquifer that rises to daylight, where a lens of less permeable material pinches against bedrock. Capillary forces help hold water within fine sediments, so the pond's edge can stand a little higher than seems possible. A meniscus of landscape. Evaporation writes the opposite argument hour by hour. But shaded rims, a small fetch that prevents waves, and dissolved salts that lower vapor pressure, all conspire to keep the mirror present longer than a casual glance would guess. In climates with a short wet season, these balances define an annual rhythm. Fill, clarify, concentrate, then rest. Mystery remains in the neatness of the outlines. Some pools are so circular, so evenly sloped, that chance feels inadequate. On granite highlands, basins appear in aligned strings, each similar in size, as if guided by an invisible stencil. Geophysical surveys sometimes reveal fractures beneath them, sometimes they do not. Radiocarbon from sparse pond muds may show centuries of intermittent filling. Optically stimulated luminescence at the margins can date the last significant aggradation. Yet the record is broken into episodes, like pages missing from a long book. In many places, the question is not whether the basin is natural, most plainly are, but why it chooses this exact measure and repeats it nearby. Biology adds another soft cause. Birds and mammals find these circles and return. Hooves press the rim, compacting soil to a denser seal. Beaks and paws clean small inlets. Wallows smooth edges that rain then rounds. Seeds ride in on feathers, germinate in the damp arc, and their shallow roots lift a thin collar of greenery that baffles wind and slows the loss of spray. The pool becomes a gentle machine, converting animal habit into hydrologic persistence. The feedback is ordinary, local, and powerful, and it helps explain how certain basins last through hard seasons that erase others. In arid Australia, rock holes serve as ancient cisterns. In the American Southwest, tanajas on sandstone hold stormwater in canyon bends. On the Canadian Shield, shallow basins on smoothed granite bedrock catch rain and snowmelts. The vocabulary changes with continent, but the practice of water collection, sheltering, slow release remains. A documented fact echoes across these regions. Indigenous communities know each pool by path and name, maintain them by clearing debris, and sometimes deepen them a handspan at a time. Archaeological traces, flakes, hearth ash, ground stone collect near dependable basins, quiet signatures of care in an otherwise spare geology. That care folds into an academic, uncertain hypothesis that some of the most perfect riverless pools are partly engineered. The suggestion is modest. Natural hollows existed, and people incrementally shaped them, grinding rims smoother, tamping bottoms, adding a ring of finer sediment to improve storage and clarity. Over centuries, the seam between origin and maintenance blurs until the basin reads as purely natural to a hurried survey. The hypothesis resists easy proof. The tools were perishable, the gestures small. Micromorphology of rim sediments and residual polish on adjacent bedrock could tip the balance, but such studies are scarce and the logistics slow. A different uncertainty concerns pools that refuse the expected chemistry. In some closed basins, evaporative concentration should push the water toward brine and crust. Instead, it stays fresh through long, dry spells. Subtle seepage from below is one possibility, a microspring that enters too slowly to show a surface disturbance, but fast enough to exchange solutes. Another involves seasonal density stratification in deeper bowls, a cooler, denser, lower layer that mixes rarely and moderates change, like a quiet memory at the bottom. Instruments record these structures when deployed, then must be carried away again as the pool shrinks. The data come in short, quiet sets, like postcards rather than letters. A poetic, rarely mentioned note arrives on windless nights. Sound changes at a circular water edge. The plain's soft hiss dims, and the small basin gathers a barely audible echo, so that a distant owl seems to speak from two places at once. The geometry of the bowl returns a fraction of the world to itself. It has no bearing on origin or age. yet observers write it down with care, a sensory fact braided to light and temperature, and the way flat water holds a sky. Elsewhere, plateaus of basalt hold pools with a different ancestry. Lava can cool with vesicles and flow-top cavities. Later, weather and dissolution enlarge them into larger bowls, where a thin veneer of soil covers the flow. Piping subsurface erosion along small pathways can collapse into neat, round sags that become seasonal ponds. These processes are mapped and measured. Still, the resulting shapes often resemble one another so closely that inventory outpaces explanation. Aerial images show a constellation of blue coins on black rock. Each coin has its own small story, and the stories rhyme. Some people have seen lights descend to bare mesas on clear nights and lift again without a trace, and they have wondered whether the perfect bowls are surveys taken from above, sampling points in a grid too wide to see from the ground. The idea travels in the quiet margins of fieldwork, not as result, not as testable claim, but as one of many human hypotheses that gather where pattern meets patience. Science keeps to slower ground. It asks what weathering can do with time, what clay can seal, what animals reinforce, what past climates left in place when they withdrew. As seasons turn, the pools shift their register of color and texture. After heavy rain, they are lapis and opaque. As particles settle, they clarify into lenses that show a pale bed, and the slow choreography of larvae, testing the edge between light and cover. Later, as evaporation works, a darker ring forms at the margin, where organics concentrate an annulus that will dry into a papery film and then into dust. When the floor finally shows, the circle remains in tone even when water leaves. A memory the next storm can find and fill with little instruction. Evening collects on the plateau. The pools fade from blue to pewter, then to a darker grey that returns the sky's last light in a single, steady syllable. No stream enters, no river runs out. The basin holds and releases like a lung, but slowly, at seasonal scale, like a planetary exhale that takes the length of a year. In maps and images, the circles appear again and again, small coherences in a wide dryness, water gathered by shape alone, and kept by the long, quiet physics of edges. Across certain plains and uplands, bowls rise from flatness with a confidence that suggests catastrophe, yet leave no broken testimony behind. The rims stand low and continuous, encircling hollows whose floors are smoother than the surrounding ground. From the air they read as textbook craters. At the surface they keep their secrets. A visitor expects to find the signatures of impact, shattered rock, shatter cones, shocked minerals, glassy sprays, but the expected evidence fails to appear. The land offers the shape without the event. Geology sets out the known checklist with calm precision. True impact scars, even when softened by time, usually carry diagnostic traces. Cones of striated fracture radiating from pressure waves. Grains of quartz transformed by microsecond shock into different optical habits. High-pressure minerals that cannot form in ordinary weather. Brecciated zones where rock fragments fuse in a sudden melt. In many of these solitary circles, there is nothing of the sort. The substrate may be clay, sand, basalt, or limestone. The sediments are ordinary. The rimstones are native and undisturbed beyond the lifting and arranging that slow processes perform. The crater-like form stands, but the language of impact remains unsaid. Accepted processes step forward in quiet variety. Some circles are Mars, broad, low-rimmed volcanoes, born when rising magma meets groundwater, and the contact flashes to steam. The explosion excavates a near-circular pit, throws a ring of tuff outward, and leaves a basin that often becomes a lake. Their diagnostic ash, cross-bedded lapilli, and country rock fragments stand as firm proof of origin where they are present. In other terrains, especially where soluble rock underlies thin soils, dolin collapse, karst subsidence draws the surface down in perfect ovals. On permafrost margins, Thermokarst sags into circular ponds as ground ice thaws and settles. On wind-worked flats, deflation hollows form, where gusts repeatedly lift fine grains from a weak patch and buttress the edge with a lag of heavier particles. Each mechanism knows how to draw a circle without a meteorite. A lesser-known detail occurs on certain sandy rims when evening wind tapers to a breath. The slope begins to sing. Grains slip in synchronized tiny avalanches and release a low, unhurried tone, an aeolian hum that lingers at the threshold of hearing. Not every rim does this. The grains must be well sorted, the humidity just so, the incline precise. Field notes record the sound as a steady vowel, rising and falling like a far engine. The phenomenon has no bearing on origin. Yet it turns the crater-like form into a small instrument that plays when the atmosphere strokes it. Mystery persists because some basins decline to fit their file. On certain coastal plains, thousands of shallow elliptical depressions drift across the map with a common orientation. Their rims are subtle rises of sand. Their floors hold seasonal wetlands that shimmer in spring and dry to patterned mud by late summer. Shock features are absent, yet the alignment repeats over county after county, as if a wind once blew with a single, enduring intent, and the land remembered. The accepted view emphasizes aeolian and lacustrine work, wind and water, organizing sediments under a climate that no longer holds. But the precision of the shared angle remains an open question. The hollows look like impact at first glance. They behave like basins shaped by years. Elsewhere, the puzzle turns on proportion. A bowl on basalt carries a rim too slight for a mar. With no ash and no country rock fragments in sight, its interior shows faint shorelines, small strand lines etched by retreating water at steadier levels, yet no inlet or outlet breaks the ring. Cores lift out ordinary silt resting on weathered flow top. The shape reads as sudden, the fill reads as slow. It is a common arrangement and a quiet bind, an outline that suggests event, a content that suggests patience. One academic, uncertain hypothesis returns whenever aligned basins gather on a plain, a fragmenting airburst in deep time, a bolide that disintegrates at altitude and strews energy across a region in uneven parcels. In this account, compressed air and downward jets scour shallow bowls. Blocks of ice from a broken comet fall as brief, heavy blows. Wind and water later rework the hollows into their present, softened forms. The idea borrows from known atmospheric explosions and from laboratory models of blast vortices on granular beds. It remains controversial, in part because the durable signatures of shock are missing, and in part because ordinary climate and wind can, over centuries, draw similar geometries. Still, the alignment of thousands of basins along a narrow arc keeps the hypothesis alive at the cautious edges of papers and at the back of conference rooms. Other uncertain proposals carry less spectacle and more chemistry. In sedimentary basins rich in methane or hydrogen sulfide, pockets of gas can accumulate beneath impermeable layers. A pressure change, seasonal, seismic, or hydrologic, could breach the cap and vent upward, eroding a circular throat and leaving a slack basin that later becomes a pond. Analogues exist in high latitudes, where thawing permafrost has produced deep, round blowouts, with steep sides and a collar of expelled earth. Applying that process to temperate zones demands careful evidence of gas migration and structure. In most cases, the proof is thin, but the idea offers a natural way to make a sudden circle without a stone from space. Facts continue to accumulate with slow instruments. Ground-penetrating radar traces, subsurface bedding around the rims, and shows whether layers drape continuously or fold into a crater-like roll. Seismics reveal the presence or absence of a breccia lens. Geochemistry checks for melt products that even erosion cannot entirely erase. Many sites return the same calm verdict. No shock, no melt, no breccia. Only the circle. and a history written in water and wind. Where Mars are present, their signs are unmistakable. Where they are absent, patience remains the likeliest sculptor. A small poetry lives in the way these hollows collect the sky. Standing on a rim at dawn, the basin appears to hold a darker version of the morning, a stillness a shade deeper than the plain. In drought, the floor prints itself with desiccation polygons and the faint tracks of beetles that travel by straight lines until they meet a curve and then choose. After rain, the waterline draws a clean annulus, and along it a necklace of foam clings and then breaks, reassembled each hour by wind. None of this resolves origin. All of it belongs to how circles behave when left alone for long intervals. The catalogue grows and stays unresolved at its edges. Some circles are clearly volcanic, some are clearly karstic, some are wind-sculpted, and some refuse these doors. What joins them is not a single cause, but a preference in nature for boundaries that minimize perimeter for a given area, a drift toward roundness whenever forces act evenly from a center, or whenever irregularities are averaged by time. A basin is a summary of events. A circular basin is a summary smoothed by repetition. The analogy is gentle and accurate. Each hollow behaves like a slow lung at landscape scale. It inhales water, dust, and seeds. It exhales vapor, insects, and silence. Over decades, it shallows or deepens by millimeters, a respiration measured not by breath, but by wet seasons and dry ones. Where human feet do come, they often walk the rim as if tracing a sentence. Where no feet come, the sentence remains unspoken and perfectly legible. Evening slides across the plain, and the crater-like bowls darken into coins set in a table of faded light. The certainty that once accompanied the word crater recedes with the day. What remains is shape, and the long, exact work of processes that do not need drama to leave form behind. The land keeps the form, and the mind keeps the question, and between them a steady, quiet stretches, round and complete. Beneath some circles, the ground opens not into a bowl, but into a throat. The rim looks ordinary stones, dust, a ring of slightly tougher earth. Yet from its center, a cool draft rises as if the plain itself exhales. At noon, the air is still. At evening, it begins to move. By night, a slow wind climbs the shaft and combs the grass around the lip. The hole is not a destination but a doorway, and under it a corridor runs, sometimes narrow as a room, sometimes wide enough for shadows to forget the walls, vanishing into a darkness that keeps its own weather. There is a firm, accepted way such corridors come to be. In basaltic provinces, rivers of molten rock once ran beneath their own crusts. The surface cooled first and stiffened into a roof. The interior stayed fluid and drained away, leaving a hollow cylinder that could extend for kilometers. These lava tubes wander with the slope, show lateral benches where levels paused, and hang with glassy stalactites. Lavasicles, where drips froze in black arcs. Much later, the roofs fail in spots and fall inward. The result is a chain of skylights, nearly circular, each marking a place where the ceiling thinned, where tension found an edge, where gravity wrote a brief sentence. From above, the line of holes reads like beads discarded in a hurry. From within, the tube is smooth and regular, a geometry drawn by flow. The relationship is exact, a perforated roof, a continuous tunnel, a pattern that repeats from Iceland to Hawaii to young basalt fields in deserts where wind has stripped the story clean. Another accepted lineage belongs to karst, the patient architecture of dissolving rock. Where limestone or gypsum lies near the surface, slightly acidic water seeps along joints, enlarging them grain by grain until conduits connect. Sinking streams, ponas, disappear into these openings and re-emerge miles away where the system lets them go. Cross-sections tell the history of water. Round, nearly circular passages where phreatic flow once filled the tube and carved evenly in all directions. Keyhole shapes where later, Air-filled flow cut a trench in the floor. When ceilings thin and fail, sinkholes form at the surface and reveal the empty below. Rims settle into tidy circles, and a loose spiral of cold air drifts upward on winter days. Warmer air in summer dropping in a barometric breathing that reverses with pressure changes, like a slow subterranean tide. A lesser-known detail lives on cave walls where these waters once pressed. The stone is scalloped, repeating spoon-shaped dimples, whose size and orientation are not random at all. Hydraulics gives their rule. Scallop length varies inversely with former flow velocity. Speleologists read the pattern as a paleograph of current, estimating speeds of vanished streams by the scale of 1,000 adjacent hollows. It is intimate, tactile science. The hand recognizes what the equation says, and it lets a corridor speak about its past even when the water is long gone. Mystery persists at the edges, where corridors behave too neatly. In some deserts, ground-penetrating radar and gravity surveys trace linear hollows beneath otherwise uniform plains, and collapse holes punctuate the line at intervals that feel counted rather than natural. The spacing repeats, tens of meters, then again, across distances that a walker could cross in an hour, and a satellite would note in a single strip. In volcanic fields, that rhythm can reflect tube mechanics, the tendency of roofs to fail where thickness cycles, where surface inflation built and relaxed. In soluble terrains, it can reflect joint spacing and the geometry of rock itself. Yet there are places where the straightness, the constancy, and the persistence through mixed soils ask for more than dissolution and flow. An academic, uncertain hypothesis follows the line of history rather than geology, that some of these regularly spaced holes are the last bright points of ancient qanats, subterranean water galleries, once dug by hand to bring groundwater gently to fields and towns. In Iran, they are qanat or karis. In North Africa, foggara. In Oman, a flage. Builders sank vertical shafts at regular intervals for ventilation and spoil removal, then connected them with a gently sloped tunnel that guided water by gravity alone. Centuries later, when maintenance ceased and roofs fell, the shafts became a dotted curve across the desert, each circle a remembered breath of the system beneath. Where documentary traces are gone and surface artifacts thin, the pattern can be taken for natural collapse until someone reads the gradient, measures the spacing, and finds a human intention buried in engineering. The hypothesis is often right, sometimes it is wrong. In a few quiet reaches, it remains all that ties order to cause. Another uncertainty belongs to loess and fine sand, where piping erosion can gnaw narrow tunnels along seepage paths, and then let the roof fail in a line of neat, round sags. The process is accepted. The stability over distance is less so. Some corridors appear to have persisted longer than their materials suggest, roofed by a skin that should not stand. Perhaps root mats once tied the ceiling, perhaps a crust of carbonate or salt formed from capillary rise and made a brittle arch. Perhaps the line is a palimpsest, several short pipes that failed in sequence and now masquerade as continuity. The ground keeps that part of the sentence unfinished. There is a small, real poetry in how many of these passages carry climate inside themselves. Air in a long tube stratifies. Near entrances, temperature follows the day, but deeper in, it settles to the mean of the local year. In some lava tubes at low latitudes, ice lingers through summers, as if the planet stores a pocket of its own winter. In karst systems under prairie, a cool breath pours out in August and writes a low fog that hugs the grass before dawn. Bats and swiftlets calibrate their flights to this weather. Crickets lay eggs where condensation beads. Thin films of manganese-oxidizing microbes paint walls with smoke-colored skins that darken over decades into quiet murals. A tunnel becomes a climate instrument set to a very long time. On certain nights, entrances sing. The shape of a vertical throat, and the speed of an evening breeze sometimes form an aeolian organ, a barely audible tone that swells and recedes as gusts rise and fall. It needs precise conditions, grain, roughness, throat length, air density, and it tells no story about origin. Yet observers write it down because sound is rare in these narratives. The corridor voices the wind and then goes quiet again. A different kind of note arrives from surveys that map tunnels under dry valleys and find they align toward vanished springs. The fact is simple. In many regions, water tables were higher in a cooler past. Conduits that once carried perennial flow are now stranded in unsaturated rock, their mouths collapsed into circular openings that seem purposeless because their river has moved below. The land keeps the hardware while the fluid retires. This explains much of the emptiness and gives a slow clock to the holes. They mark where water once chose to travel when climate spoke another dialect. Some people have seen lights skim the horizon and dip toward lonely mouths, seen instruments lose radio quiet near certain entrances, and wondered whether the corridors collect more than wind, whether their straight stretches are attractive to observers, not of the landscape, mapping by echo and retreating before day. The suggestion remains a rumor beside careful work. Science holds to what can be weighed: flow marks, mineral skins, void geometry, barometric breathing, the steady arithmetic of spacing. In all of it, roundness returns. Skylights attain a circle because stress distributes evenly around a hole. Sinkholes round themselves as edges slough in and minimize perimeter. The atmosphere prefers smooth flow, and so sculpts throats that do not snag the wind. The analogy is gentle. A tunnel system behaves like a sleeping animal under the plane, inhaling and exhaling slowly with pressure and season, its lungs marked on the surface as small, precise openings. Night gathers, and the breeze at the rim cools a degree more. Down below, air slides along stone polished by vanished rivers and stone varnished by fire. Dust settles. A moth hovers at the boundary where day's heat meets cave chill, and then chooses the darker air. The corridor keeps its line, patient and undecorated, and the circle above keeps its edge, a perfect punctuation in the middle of nowhere, reminding the surface that the ground is not solid all the way down. On young volcanic plains, the earth leaves small, round signatures that look like breath held and released. The ground is dark and porous, a skin of basalt that still remembers heat. The air smells faintly of eggs and damp metal. Here and there, circles interrupt the flatness, shallow pans rimmed by pale crusts, puckered mouths with warm air rising, or tidy collars of ash around empty centers. Nothing violent announces them now. The land only exhales thinly and marks the place of its exhalation with a ring. The accepted processes begin where magma and water meet without flame. When rain or groundwater seeps toward residual heat, fluids vaporize and expand. A fumarole opens a vent that issues steam, carbon dioxide, sulfur dioxide, hydrogen sulfide, and other gases. The plume is invisible in dry light, then a gauze in cool morning. Around the vent, hot acids alter rock to clays, iron to ochre, and rims weaken. Ceilings slump into neat, circular pits. Elsewhere, hydrothermal systems charge themselves like coiled springs as steam builds beneath a seal of clay or sinter. When the pressure overcomes the cap, a hydrothermal explosion excavates a low, round crater that later fills with blue water or white crust, a circle left by sudden vapor. On basaltic fields, another mechanism writes circles with steam but without a conduit to the deep. When lava flows across wet ground, lake margins, or boggy soils, trapped water flashes, the burst moves upward through the flow, tearing a hole and building a cone of spatter that looks like a volcanic vent but is not. Iceland gives them a name: pseudocraters, or rootless cones, because they root in water and heat, not in a magma pipe. From above, chains of these small craters make necklaces across lava plains. each bead a record of where the flow passed over wetness, and let steam speak in a round syllable. A lesser-known detail gathers overnight on the cooler margins of vents. In the hours before dawn, when air temperature dips and plumes thin, sulfur vapors condense into delicate filaments and tiny crystals on the leeward side of rocks, flowers of sulfur, a transient frost that yellows the ground with downy bloom. When the first light touches the rim, the crystals soften and slump, returning the color to a dull crust. Field notes write this down because it vanishes by breakfast. A brief, quiet botany of minerals that the eye would miss if it arrived with the sun high. Facts line the rims. At fumaroles, geochemists log gas ratios that change with depth and time. The proportion of CO2 to SO2 and H2S tells whether fluids rise from degassing magma or from boiling groundwater. Clay minerals such as kaolinite and alunite form in the halo, and their assemblage speaks a tight dialect of temperature and acidity. At hydrothermal craters, glassy shards and sinter fragments lie mixed with country rock. Shock is absent, but the chaotic texture confirms rapid expansion. At rootless cones, bombs and spatter derive from the surface flow itself. Beneath, the throat ends where the lava meets sediment. These signatures hold across volcanic provinces, from the high plateaus where snowmelt feeds steam, to coastal plains where basalt remembers the sea. Mystery persists, softly, in the spacing and persistence of certain circles. Some degassing fields spread as grids, vents repeating at intervals that seem more exact than fracture maps predict. Others migrate, fading in one spot and brightening in a new ring, a few meters away, as if the subsurface breath chooses a different reed to play. A pattern may follow an unexposed dike or fault. It may reflect a wandering pocket of heat. It may be a map of permeability that instruments have not resolved. The eye, seeing repetition, asks for a rule. The rocks, speaking by alteration and temperature, answer in fragments. One academic, uncertain hypothesis proposes that a subset of enigmatic, perfectly round pits on certain volcanic plains are the scars of Moffett pooling places, where heavy CO2 has accumulated in shallow, undrained depressions and quietly killed vegetation, allowing wind to winnow fine grains and fix a self-maintaining bowl. The chemistry is real. Carbon dioxide sinks and can make low pockets lethal, as seen on slopes where soil gas rises from deep faults. Whether such pooling, without the help of a strong plume or running water, can sculpt persistent, symmetrical circles in rough basalt remains in question. Micromorphology of sediments and careful CO2 flux mapping could test it. In most fields, the data are scant and seasons short. Another uncertain line runs deeper. Geochemists sometimes find mantle-like CO2 isotopic signatures above volcanic regions that show no recent eruptions. Some suggest long-lived degassing pathways, fractures, and faults that leak quietly for centuries, painting the surface with rings of altered ground and low plant vigor. The idea is modest and hard to prove. A breath without a voice, a vent without a cone, a circle kept by chemistry alone. Thermodynamic models can accommodate it. Field verification lags in remote districts where roads end before equipment grows sensitive. At the gentle edge of speculation, observers on night patrols describe lights that hover over certain vents and sink until their glow dims to nothing, then reappear. Instruments click, cameras wash with heat haze and fail to focus. The accounts remain at the periphery of reports, no more decisive than mirage. Still, they circulate like rumors of weather, and the circles warm, altered, patient, are easy places to assign a visitor's pause. Science notes the stories and returns to gradients and mineral skins. Elsewhere, volcanic breathmarks shift medium and occur on water. In shallow lakes underlain by faulted volcanic ground, Colorado, two seeps rise in chains. Each bubble stream dimples the surface. Each cluster scours a tiny, round pan in soft sediment below. Over years, the pockmarks coalesce into tidy fields of circular hollows, aligned with a buried fracture that meters the gas. The pattern is particularly neat, where currents are gentle and bioturbation is light. Sonar maps render these underwater rings as evenly spaced dimples, a relief of respiration slowed by depth and time. A small, practical poetry belongs to animal behavior around vents. In cold months, insects and small reptiles warm themselves at the margin where hot air lifts from a rim only a few degrees above ambient. Birds learn the circles as winter larders and pause to glean. In high country, snow melts in annuli around active vents, and the white field shows a stippled pattern of circles long before bare ground emerges elsewhere. These are reliable signs with no mystery, the kind of patterns that make maps read like calendars. When wind drops at dusk, certain pits on cinder fields pulse with a soft, breath-like haze, as condensing moisture makes the exhalation visible for a few seconds at a time. The metaphor becomes literal then. The volcano breathes. The analogy is fair and gentle. Degassing and hydrothermal systems are the slow lungs of a cooling crust. Circles at the surface are fingerprints left by that respiration on days when heat finds a weakness and chooses geometry. Over decades, circles change register. Fumaroles clog, blow out, or move. Hydrothermal craters fill with pale clay, then water, then a raft of microbial mats that paint the surface with browns and acid greens. Rootless cones weather to low rings, their inner slopes grayed and gentle. Geologists return, measure gas, tape cracks, log temperatures, and pin cuff tags to dates and locations that the wind immediately chews. The landscape keeps its own records more durably. Mineral halos, clay seams, round basins that reform as if the plan were part of the ground's quiet memory. By night, the breath thins and the smell of sulfur softens to a sketch. Stars nest in the dark bowls where water has gathered. In dry pits, cooled gases slump and make the air heavy in the lowest inch. There is no flame, only chemistry and slow physics. The circle remains because forces radiate, because pressure favors symmetry, because perimeter shrinks when boundaries are neat. The plane accepts these terms. The rings hold their tone without insisting on an answer. Where the ground stays cold from within, while the sky burns with summer light, circles appear that belong to both seasons at once. On tundra and high plateau, moss lies like a pelt over frozen soil, and the air moves in long, level strokes. Here, round forms repeat with quiet conviction, bare discs of silt ringed by greener rims, raised collars of peat surrounding shallow hollows, ponds as even as coins, mounds with icy hearts that lift and then fall. The land practices geometry with frost and with thaw, with ice and, sometimes, with fire. An accepted process anchors the scene. In periglacial soils, water migrates toward freezing fronts and grows ice lenses perpendicular to the temperature gradient. As lenses thicken, they heave the surface, lifting fine grains and pushing stones aside. When thaw comes, the disturbed materials settle unevenly and begin to sort themselves. Over many cycles, soil organizes into patterned ground, stripes on slopes, polygons where ice wedges crack and heal, and, on gentle flats, sorted and non-sorted circles. In the sorted kind, a naked disk of fine sediment lies at the center, and a ring of stones frames it. In the non-sorted kind, a low dome of fines sits within a shallow moat of wetter ground, the ring visible as a shift in vegetation and tone. The physics is steady and real freeze-thaw convection, differential heave, buoyant rise of clasts, self-organization written by temperature and water. A lesser-known detail lives at dawn in early autumn. Needle ice grows from the bare centers of frost boils, lifting grains on hair-thin columns a few centimeters high. When the first sunlight reaches the disk, the needles collapse with a faint, collective crackle. A person who stands downwind hears the circles settle like paper. Later, when the day warms, the darker central soil dries faster than the rim and exhales a little dust that drifts outward and catches on the moss. Over weeks, the rim darkens by a shade, simply because it is a net that holds the plain's fine breath. Across peatlands, another accepted form rises. The pulsar or lithalsar, a low, domed mound with an ice-rich core. Winter cold builds segregated ice within saturated peat. Summer warmth cannot fully remove it beneath the insulating moss and lichen. The mound lifts by decimeters, often roughly circular in plan. When the ice core finally decays by warming climate, wildfire, or a breach in drainage, the surface sags into a nearly round hollow, often with a shallow moat of wetter ground where meltwater gathers. Around some old pulsars, the former shoulder remains as a ring of slightly higher peat, a rim that greens first in spring and turns first in fall. Mystery persists in the scale and spacing. On certain Arctic benches, stone ring diameters cluster in narrow bands as if chosen, repeating 5 to 7 meters again and again across hundreds of meters. Models reproduce the basic tendency towards self-chosen wavelengths under periodic freezing. But why one site prefers 4 meters and another 8, with similar climate, grain size, and slope, remains an open question. Subtle variations in soil salinity, organic content, or snow trapping may tune the pattern. Field measurements are delicate, seasonal, and slow to accumulate. The circles keep their dimensions with a stubborn grace that theory only partly matches. Another uncertainty belongs to rings that wake after wildfire. When a burn removes the insulating mat of moss and lichen, albedo drops and summer heat runs farther into the ground. In some peatlands, circular thaw patches open, where the organic layer was thinner and the ice richer. Rims stay cooler where moisture lingers. Over a decade, the fire scar reorganizes into a field of dark discs with green collars. Thermokarst translated into geometry by insulation alone. The accepted mechanics heat flow, moisture redistribution support the appearance of circles after fire. Yet the regularity of spacing in certain burns suggests a pre-existing, hidden order that the flames merely revealed. The pattern looks new. The template may be old. Facts add texture underfoot. On the fine-grained centers of frost boils, lichens are scarce, and annual plants find brief advantage in the early thaw. On the rims, sedges and dwarf willows root deeper and persist. Soil pits show a lens of coarser material just beneath many rings, a lag that drains faster and keeps the rim drier. In polygon fields nearby, ice wedges crack audibly in midwinter during sharp cold, a brittle report that moves across the plain like a slow spark. Spring melt runs along the wedge troughs and gathers in rounder sags where wedges intersect, a hydraulics that lets circles live within a larger graph of lines. A small, seldom mentioned note belongs to the drunken forest at ring margins. As ice degrades unevenly, black spruce and larch lean in consistent directions, their root plates tipped by thaw under one side of the trunk. Where rings expand slowly, a crown will tilt, correct, and tilt again, recording decades of ground motion in wood fiber like tree ring microcisms. The trees do not last long, but while they stand, they point to geometry as surely as a compass. One academic, uncertain hypothesis steps beyond slow physics and asks whether certain, sudden, steep-walled, perfectly round tundra holes are cryogenic gas release craters, brief explosions where pressurized methane, freed by thaw at depth, vents upward and throws a collar of earth around a fresh shaft. The idea is built from documented blowouts in high-latitude lowlands and from elevated methane in surrounding lakes. Extending it to every neat circle would be wrong, but for a subset of deep, sharp-edged forms with ejecta, it remains under study. If true, some rings are moments rather than millennia, quick breaths rather than slow ones. ice turning to gas, and back to silence in the span of a storm. At the very edge of the conversation drifts a gentler speculation carried by observers who travel nights when aurora lifts the snow into slow color. They have seen pale lights sit low over certain Thor circles and depart, leaving nothing but hoarfrost pushed in a ring, as if a heavy, cold air had pressed down. Some people speak of visitors measuring the ground and moving on. The reports stay in margins and do not enter measurements, but they reside near the work the way campfire stories reside near maps. Meanwhile, instruments return to temperatures, pore water pressures, grain sizes, and the annual phase of freezing fronts. Fire belongs to the circles in quieter ways too. In late summer, zombie fires smoldering peat that overwinter beneath snow resurface and creep along the driest rims, outlining discs with a faint smoke that rises straight in calm air. The heat dries and lowers the rim a little more. Winter then builds thicker ice lenses within the exposed center. The next thaw exaggerates the step between inner and outer ground. The ring sharpens by a feedback of burn and freeze, an alternating current of seasons that turns variability into edge. Under shallow lakes on continuous permafrost, round moats open in winter around small islands, as heat from groundwater and darker shorelines eats the ice from below. These collars of thin or absent ice reappear year after year in the same widths, a geometry set by currents and by the insulating snow blown from open water onto thicker sheets nearby. When the lake drains during a late-season breach and leaves a dry bed, the moats remain as damp rings that green first, a submerged circle translated cleanly onto air. Even sound recognizes these shapes. On still, bitter nights, the plain creaks as contraction cracks propagate. Where a thaw circle stays unfrozen longer, the crack detours, skirting its edge and closing with a short hiss as snow sifts into the gap. The noise is unremarkable and exact. A listener can map a ring by ear in darkness, tracing the quiet geometry through small changes in tone. What returns, always, is the way symmetry purchases efficiency. Roundness minimizes perimeter for a given area. Heat and cold, pressure and thaw, flow and rest all favor boundaries that distribute strain and work evenly. The analogy is gentle. Each frost circle behaves like a slow clock the size of a room, ticking with seasons rather than seconds, counting by freeze and by thaw. The clock does not hurry. It keeps the time of shallow water and low sun, of moss and silt and small stones that remember where they belong. When the midnight light finally lowers enough to cast a shadow, the rings darken and then ease back into the general grey of the plain. Ice remains in the ground, fire waits in weather and in the carbon of peat. Between them, the circles continue, repeating with patience, practicing their quiet arithmetic in a place that prefers evenness to edges and rest to motion. Shallow seas keep their own archive of circles. Far from harbours, past the colour change where sand gives way to silt, the seafloor dips into tidy bowls the eye cannot see from a boat. The surface stays plain. Wind writtens its short script and moves on, while below, round depressions repeat with a patience the tide cannot erase. Sonar finds them first. Multibeam swathes render the bottom as shaded relief, and across those grey landscapes the dimples appear. Dozens, hundreds, sometimes thousands, each a measured hollow with a rim as quiet as a breath. One accepted process writes many of these forms. Seafloor pockmarks, circular to oval depressions, from a few meters to hundreds across form, where fluids or gas escape upward through soft sediments. Methane and carbon dioxide rise in strings of bubbles. Pore water, lighter than its surroundings, moves along buried sand lenses. The flow destabilizes silt and carries grains into suspension. Over time, repeated episodes of seepage scour a bowl and maintain it. Echo sounders record bubble flares as bright pillars. Sub-bottom profilers show acoustic blanking beneath active sites where gas absorbs the signal. Around persistent seeps, Chemosynthetic communities take root, bacteria oxidize methane, and their work leaves orthogenic carbonate crusts that ring the depressions like thin, pale collars. The chemistry is modest and exact. A gas becomes food, and food becomes stone that belongs only here. A lesser-known detail threads through slack tide. Where bubble streams rise in clear water, sunlight breaks on each sphere and stacks a silver column that shivers, but holds its place for minutes at a time. Put a small hydrophone nearby, and the column speaks a continuous needle fizz, a sound too fine to hear in air. Divers who work long transects say that at certain hours the seafloor sounds like rain reversed, a steady upward patter that holds even when the surface is glass. It changes nothing about origin, but it fixes the bowls in memory as places where sound ascends. Facts collect in cores and on screens. In many pockmarked fields, the depressions align along buried faults or the margins of ancient channels. The pattern maps structure under sediment as faithfully as a paper trace. Carbonates precipitated around seeps often carry carbon isotopic signatures depleted in Derm-Pagupsi, evidence of methane oxidation rather than ordinary marine photosynthesis. Some pockmarks are rimmed by low mounds, where escaping fluids cement particles. Others host mussel beds or mats of filamentous bacteria that texture the bowl with a pale nap. On young shelves, new pockmarks appear over years. On older ones, bowls persist long after active seepage wanes, their geometry maintained by small bottom currents and by the reluctance of still water to refill exact forms. Mystery remains in the many circles that are not visibly active at all. Entire fields show no bubble flares, no modern carbonate crusts, no chemosynthetic fauna, yet the bowls look recent and regular, as if something in the past pressed outward and then fell silent. How often do these systems breathe? A single storm, a small earthquake, a change in pressure at depth can open a path and then seal it again. The record, when it exists, is a stack of laminated muds on a bowl floor, interrupted by thin, disturbed layers that read like sudden words. In most places, cores are too few to connect bowls to their sentences. Elsewhere, the sea chooses depth rather than width. On carbonate platforms and banks, the bottom drops into blue holes, circular shafts cut into limestone during low sea level stands and later flooded by the sea, their throats round where rock failed evenly. Below, the water stratifies into sharp, persistent layers. Warm, oxygenated surface water rests above cooler, darker brine. Between them, a chemocline forms, a milky band where bacteria graze on sulfur and turn the water to pale smoke. Hydrogen sulfide accumulates below. Oxygen vanishes. Divers describe a boundary that looks like fog underwater. Cross it, and the light dims, not by depth but by chemistry. Great cones of still sediment ring the base like unpoured flour. The whole is a circle of time as much as space, a watertight archive that keeps fragility intact in anoxic dark. Even at the scale of fish, circles appear. In seldom visited coves, male pufferfish sculpt sand mandalas, meter-wide rings, with radiating ridges and a smooth central cradle, by beating their fins and mouth to move grains into a precise relief. The structures are shallow and ephemeral, erased by the next squall, made anew in another place. They are not holes and not pockmarks, yet they teach how much symmetry the sea will tolerate when work is small and persistent. Ridges hold, bowls center, circles repeat. The lesson is gentle and lives well beside larger geomorphology. Uncertainty gathers around other subtidal rings. On some inner shelves, mosaics of side-scan sonar show perfect circles 10 to 20 meters across, each a shallow depression with a slightly raised rim, spread in loose grids far from cables, anchors, or trawl scars. Current meters register weak, oscillatory flow. No gas flares, no carbonate collars. The pattern is too uniform for burrowers, too tidy for random scours. One academic, uncertain hypothesis proposes vortex moats, stable, circular eddies set up by standing waves or tidal resonance that focus shear on the bed at discrete nodes. In flumes, coherent vortices can cut bowls in fine sediment and hold them against small perturbations. Whether such structures can persist in open shelf conditions long enough to write fields of perfect rings remains unproven. The sea is a generous laboratory, but a difficult one to instrument at the right scales for long enough. A second uncertain line of thought looks to climate history. During the last glacial cycles, grounded icebergs raked many shelves, leaving gouges and pits where keels struck bottom. In some banks, circular iceberg pits more bowl than groove dot the map and predate modern sediment rain. Over millennia, currents winnow these forms and blur their edges. Still, where sedimentation is slow, the pits remain remarkably crisp, ancestral circles repurposed as habitats for modern communities. Distinguishing ancient keel pits from young pockmarks or vortex moats can hinge on a single buried reflector in a seismic line, or on the sorting of grains in a rim a few centimeters thick. The evidence is there, but thin. The question travels with each survey. A quieter uncertainty belongs to submarine groundwater discharge, where coastal aquifers meet the sea. Freshened, cool water can seep upward across wide areas. In fine sediments, that rise may flocculate clays or mobilize pore water enough to cause slight deflation. A stable seep could then maintain a shallow, circular depression without bubbles or chemistry that shouts. The hypothesis asks much of weak forces. It fits neatly where blue lenses of low salinity pore water have been mapped, and poorly where the shelf holds only uniform brine. It waits, like many shelf ideas, for long deployments that small budgets rarely allow. Through all of it, the sea does the steady work of sorting. Grains saltate along the bed, waves run their orbits, and even a light current exaggerates edges by carrying fines out of hollows and letting them settle beyond. A circle once begun is easier to keep than to erase. That is the simplest analogy. Each bowl is a low lens that gathers motion and returns quiet, like a slow, planetary exhale, trapped underwater, inhaling silt and exhaling clarity in a rhythm measured by tides and storms rather than breath. There is poetry in the life that edits these forms without altering their argument. At active seeps, white microbial veils billow like soft flags. Amphipods graze the edges. Small fish sleep in the lee of rims when the moon slackens the tide. Over a pockmarked field at night, a scattered constellation of bioluminescence answers the bubbles, so the upward columns spark and fade in miniature weather. None of this assigns an origin. All of it turns a map into a place. Stories travel along the gunwales of small boats about lights that pause above calm water, sink without splash, and leave a ring of silvery fish stunned at the surface. The reports sit at the margin of careful work, adjacent to it but not entangled. Instruments speak more plainly. Pressure, grain size, gas ratios, current vectors, isotope values. Even so, the circles invite rumor because pattern and quiet always do. By morning, the surface is untroubled again, a plane of light stitched by ripple. The bowls below remain, invisible to the eye and perfectly legible to sound. Charts mark them, trawls avoid them, sediments remember them. Roundness repeats underwater for the same reason it repeats on land. Forces radiate, edges minimize, and time takes any sharpness away that is not maintained. In that economy, the sea keeps its disks where no wake sees them, and the mind returns to their unseen geometry the way a tide returns to an unmarked shore. Across dry grasslands that seem uniform from a car window, circles of greener life interrupt the sameness with a quiet insistence. The plain holds a steady tan until, without drama, a rim of brighter vegetation closes around a paler center. From the air, the pattern clarifies. Rings repeat at roughly even spacings. Some only a few meters across, others large enough to map as neighborhoods of color. Drones record them as annuli with a thin, vigorous band and a subdued interior. Satellites render them as halos in chlorophyll indices, the rims glowing slightly higher than the background field. An accepted process explains much of what appears in deserts from the Namib to parts of Western Australia. In arid soils, plants compete for scarce water. Their roots deplete moisture close to the stem and leave a drier shadow that suppresses neighbors. Farther out, where roots do not overlap, water lingers and seedlings survive. Over time, self-organization emerges from this simple contest. Vegetation withdraws from the center and stabilizes on a ring where water is maximized by distance from competing stems. Mathematical models capture the dynamic as a reaction, diffusion, analog biomass and soil moisture, playing the roles of activator and inhibitor, and predict the observed wavelengths between rings. Field measurements agree in essential ways. The rim soils are moister after rare rains, and the center crusts dry faster and harder, discouraging roots. A lesser-known detail lives in the first hour after dawn during fog events along coastal deserts. The rim's taller, rougher blades strip droplets from passing mist and bead them at their tips. Small amounts fall as micro-drip to the root zone, a dew subsidy so slight it evades most gauges. Even when fog does not appear, the ring cools a fraction more overnight than the bare patch, and that difference is enough to condense a film that the next light eats away. Observers note a faint, sweet petrichor along these halos after still mornings, though no storm has passed. Not all green circles belong to deserts. On temperate lawns and meadows, fungal fairy rings derive from a different, equally accepted mechanism. A mycelial network grows outward in a low, expanding circle, consuming organic matter and exuding nitrogen and growth-regulating compounds near the advancing edge. Grass at the front darkens and thickens. The interior, where the fungus has depleted resources or rendered soil temporarily hydrophobic, pales. Some species ring themselves with mushrooms after rain, a transient punctuation that confirms the hidden geometry. Soil assays show elevated ammonium near the green band. Penetrometers find tighter, waxy aggregates where hydrophobic films form. The circle persists and wanders slowly outward year by year, a living wave in quiet motion. Mystery persists in the scale and spacing of the arid land halos commonly called fairy circles. In some regions, their diameters cluster in strikingly narrow ranges, and the distances between ring centers repeat as if tuned. Models that blend vegetation feedbacks with subsoil processes reproduce patterns generically. But why one site prefers 6-meter disks and another 10 under similar rainfall and soil grain sizes remains unresolved. Termites enter the conversation with evidence and caveat. Excavations reveal sand termite galleries in and around many Namib circles, where colonies remove vegetation and ventilate the soil. Water infiltration increases in the bare patch and is stored at depth, available to perimeter grasses whose roots can reach it. In other landscapes with similar rings, termite signs are sparse or absent. The weight of data suggests multiple mechanisms can converge on the same geometry, with their relative importance shifting by place and time. Facts accumulate in instrumentation that watches vegetation breathe. Time series from satellite indices show rims brightening and fading in cadence with seasonal rain. Microwave backscatter responds to the rim's higher moisture. Electrical resistivity transects confirm wetter subsurface arcs after storms. In a few sites where long-term monitoring is possible, the ring diameter oscillates over decades, not linearly expanding or contracting, but moving within a band as droughts and pulses play out. The oscillation hints at coupled feedbacks. Roots deepen, soils seal, termites shift, rain patterns change, and the ring finds a new compromise without losing its circle. Another class of rings grows by patience rather than competition. In North American and Australian deserts, old clonal shrubs push their stems outward as interior branches die, so that the plant becomes a shrub ring, a circle of living growth encircling woody memory. Creosote, in particular, builds such forms on coarse alluvium. Genetic tests show single individuals spanning tens of meters, their centers desert-paved and quiet. The accepted cause is simple, autogenic succession. Light and nutrients favor the perimeter, while interior, shade and litter suppress recruitment. The ring advances slowly, a botanical clock that counts centuries one leaf edge at a time. Uncertainty belongs to circles that surround springs too shy to be called springs. In some semi-arid basins, faint halos of greener grass appear over microseepage zones. Places where small fluxes of deeper water rise through fractures or sandy lenses, and then evaporate near the surface. Salts accumulate at the exact center and punish growth. A ring thrives where freshened moisture sighs outward and salt concentrations drop. Isotopes of hydrogen and oxygen in rim water can betray a deeper source. Often, the signal is mixed, the flux small, the logistics hard. The hypothesis fits neatly in some fields and poorly in others, and remains a gentle explanation rather than a general one. A small, tactile note resides in the rim's texture under wind. The band of thicker stems roughens flow, slows it just enough to drop dust and stray seeds, and so thickens further. Over months, a lace of biological soil crust, cyanobacteria, and lichens laces the bare patch and strengthens its resistance to raindrop impact. The interior holds together and repels water. The rim accepts and infiltrates it. A ring is therefore a machine built of friction and porosity as much as it is of roots, a shape that edits passing air into a resource. One academic, uncertain hypothesis reaches for signals deeper than plants. Some geobotanical studies propose that subtle, circular vegetation anomalies can ride above buried pipes, tanks, or metallic objects that conduct heat or alter soil moisture, producing green rings by unintended microclimates. Extending that idea to remote, artifact-free savannas is difficult. Yet, in a few former test ranges and abandoned fields, shallow subsurface structures do impose neat halos in grass. The mechanism, thermal inertia, and water redistribution is sound. Its relevance to wild circles is limited and site-specific, but it reminds that living patterns can reveal unseen things with indifferent fidelity. At the peripheral edge of reports, travelers speak of lights resting low over empty plains and lifting quietly. And in the morning a ring seems greener there, or a circle of lodgepole bent in one direction, or a dew rim pressed. The accounts do not enter journals. They sit near maps like weather that never reaches a gauge. The work returns to transects, to roots and water and insects in sand, to equations that push biomass outward until geometry holds. Elsewhere, very small rings grow at the scale of single shrubs. Nebka's dunolets, built by plants, develop collars of sand that, after a plant dies, persist as low circular levees. In wet seasons, water stands inside the collar and favors a halo of annuals. In dry seasons, the low wall catches drifting litter and seeds. The ring's crest warms and cools faster than the plane, inviting insects that carry pollen from circle to circle and stitch the field into a slow exchange of genes. Roundness returns for familiar reasons. The rim occupies a line equidistant from stresses inward and outward. It minimizes perimeter for the biomass it can sustain. It distributes transpiration and shade uniformly. The analogy remains gentle and fair. Each vegetation ring is a slow diaphragm on the land, inhaling scarce water along its edge and exhaling it as cooled, moistened air. In a windless noon, the band sheds heat a fraction faster than its center. At night, it radiates and draws a thin breath of denser air downslope. The movement is not dramatic. It is enough. Evening lowers across the plain, and the halos dim to barely different greens. Small moths work the rim flowers. Ants carry seeds along the circumference and bury them at a depth set by habit more than intent. The center keeps its pale crust. The ring keeps its quiet vigor. The spacing holds, though no fence is visible. The map of circles remains as the light falls away. Not a code, not a message, only a repeated solution to the same spare equations of water, heat, and space. In flat country, where horizons run unbroken and heat turns distance into a trembling film, white circles shine from the ground as if a pale moon had lowered itself and left its outline behind. The rings lie on hardpan and clay pan, on basalt flats thinly dusted with silt, around lonely seeps where water never gathers enough to call itself a pond. From far away they look chalked. Up close they are a crust that crunches underfoot, a collar of crystals that brightens in dry light and dims when wind lays a veil of dust across it. The accepted process begins below the surface, in the quiet space where pores hold water against gravity. In arid basins, a shallow water table or a perched lens feeds the capillary fringe. Dissolved salts, chlorides, sulfates, carbonates ride upward in that thin film. At the surface, evaporation outruns supply, and the water's retreat leaves efflorescence behind. Halite plates build themselves along grain edges, gypsum needles weld into rosettes. Then the next breath of moisture dissolves and resets the front by millimeters. The geometry follows physics. Wherever the balance of upward wicking and outward evaporation meets a boundary, precipitation sharpens into a ring. Around a seep, the fringe spreads as a dome and draws a halo at its margin where fluxes change slope. As seasonal water stands and then thins, chemistry writes a second mark. Evaporation concentrates brine and moves the shoreline inward. At each pause, a light bathtub ring sets, a barely raised line that maps a level the wind once defended. After the last puddle vanishes, those rings remain like growth bands in reverse short records of a season's retreat. When the next shower passes and pools reform, new lines stack above old. Where years go dry, the record erodes into a single white band that seems inevitable. Though it is the sum of many hesitations, a lesser-known detail belongs to night. Hygroscopic salts wake before dawn. Magnesium chlorides and bittern mixes draw moisture from the air and soften the crust to a damp sheen. In a still hour, a listener can hear a faint crepitation as thin films advance and retreat across crystal faces, like paper settling. In midwinter, on certain alkali flats, mirabolite, the decahydrate of sodium sulfate, blooms overnight into cottony mounds that blue the moonlight, then collapse after sunrise as the hydrate sheds its water and returns to powder. The transformation is quick and quiet. Field notes remark on the way a ring appears to breathe once, visibly, in cold morning. Elsewhere, pressure from below writes the circle in a different way. On the flanks of confined aquifers, the land bears mound springs, low domes of calcareous or silicious deposit capped by marsh and ringed by salt. Water rises under artesian head, spills at the crown, and evaporates at the margin. Calcium carbonate or silica falls out at the center. Gypsum and halite fringe the edge. The build is slow and patient, a centimeter in many years, a meter in many centuries. Around each mound, a pale halo develops, where capillary rise keeps the surface bare and bright. And beyond that halo, halophytes, samphire, saltbush gather in a narrow belt that can be seen from the road as a greener ring. The fact is durable. Pressure and evaporation collaborate to draw circles without hands. On soda lakes, the palette changes. Waters rich in sodium carbonate precipitate trona and narcolite as brines cross thresholds set by temperature, pH, and carbon dioxide exchange. The precipitates form rafts and shore collars. Microbial mats bind grains, trap bubbles, and grow stromatolitic textures at the edge. Under certain iron-bearing waters, halophilic microbes charge the ring with carotenoid reds and oranges, a thin, living annulus that follows salinity as closely as any contour line. A microscope sees filaments and plates. A satellite sees the ring in shortwave infrared, where gypsum's hydration bands and halite's brightness separate cleanly from clay. Mystery remains in circles that are too neat and too regular for simple seepage alone. On basalt pavements with no obvious depression or spring, pale halos appear in even spacing after a wet winter and persist, then fade together years later. Some align loosely along a buried fracture. Others form grids, as if answering to a wavelength rather than a pipe. The field plots show no strong topographic control. Electrical resistivity finds shallow contrasts that come and go. Chemistry speaks in ordinary ions, with no exotic trace to betray a singular source. The rings keep their distance from one another, as if by agreement. One academic, uncertain hypothesis proposes that these halos are a self-organized precipitation front, a reaction diffusion system in soil, where salt transport, evaporation, and surface sealing interact to stabilize rings at a preferred scale. In this view, crusting inside the circle reduces infiltration and pushes the wetting front outward. Capillarity then feeds the rim, where evaporation and precipitation peak. As the interior seals more, the ring sharpens. As seasons change, the system drifts, but returns to its scale. Models can grow clean discs with parameters drawn from laboratory columns. The field evidence is suggestive, alternating bands of porosity, slight hydrophobic films, but incomplete. Microbial mediation may tune the result. Halophiles stabilize crust here, disrupt it there, adding biotic feedback to mineral physics. A quieter suggestion links some rings to microseepage of CO2 from depth, along faults too tight for water to rise. The gas dries the near surface by raising vapor flux. It acidifies pore water slightly, nudging carbonate equilibria. It suppresses certain plants and favors others at a narrow distance, where the effect weakens. Surveys in a few volcanic back basins show coincident CO2 flux and salt halos, but proving causation across wide plains, where flux is low and variable, has proved hard. The circles could ride above gas that breathes seasonally, or they could be coincidence laid over structure. Facts have their own quiet authority at the grain scale. Subfluorescence, crystal growth within pores, exerts enough pressure to pry aggregates apart, granulating a crust from the inside. Repeated hydration, dehydration of mirabolite and epsomite bulks and shrinks volumes by tens of %, and cracks the surface into frail plates that the next wind removes from the center and leaves at the rim. Under a lens, halite overgrows form hoppers and chevrons that record humidity history in angles. Under boots, the ring resists where the center powders. Remote sensors pull these behaviors apart by tone and spectrum. The ground folds them back together into a single, simple brightness. At the scale of habit, animals and plants write margins. Brine flies rise in sheets when a step disturbs a ring and then settle again like soot. Small waders pick the band for invertebrates concentrated by chemistry. Ungulates skirt the crust and browse the halophyte belt where salts are lower. Seeds accumulate along the line where breeze slows over rougher stems. In drought, the ring holds odor longer and becomes a path in the dark for animals that travel by trace. None of this decides origin. All of it keeps the circle visible to time. Stories travel with field crews about nights when a light pauses above a salt pan and lowers without sound. And in the morning the ring under it seems cleaner, the crystals sharp as if newly precipitated. The accounts float where wind floats. Instruments speak more plainly. Still, circles that appear and fade invite rumor, because repeated geometry looks like intention, even when it is only the consequence of gradients and time. Even uncertainty has edges that can be felt. When rain finally falls after a long dry, the ring turns grey, then brown, then briefly disappears beneath a slick. Hours later, a white line returns at the same radius, sharper than before. The analogy holds and stays gentle. Each salt halo behaves like a diaphragm on the land, drawing dissolved matter outward and exhaling it as crust along a perimeter that minimizes effort. Like a planetary exhale slowed to seasons, it marks where invisible flow returns to air. Evening lowers, and the rings cool a fraction faster than the surrounding clay. Dew finds them first and writes a darker annulus before the stars. In that short interval, the white softens, the crystals darken, and the ground seems to loosen its hold on light. By midnight, the sheen fades. By dawn, the crunch has returned. The circles keep their quiet brightness by the arithmetic of evaporation and capillarity, and the basins hold their story with the patience of minerals that only ask for air. In a few dry channels and on wave-cut benches where bedrock lies open to weather, round holes descend with the regularity of a drill, their walls satin smooth, their floors cupped as if a careful tool had withdrawn. Some show faint spiral grooves that wind downward like threads cut into stone. Others are cylinders so true that a hand passed around the inside finds no snag. They collect rain for an hour and keep shadows all day. From a distance, they read as punctuation orderly periods in slabs of granite, basalt, or sandstone, older than the nearest settlements by many lifetimes. The accepted process that explains most of these shapes is patient and mechanical. In fast, shallow flow, a stone becomes trapped in a small depression and begins to circle under a vortex, abrading the hollow deeper as it turns. More pebbles join, sand suspends, the vortex strengthens, the toolkit improves. Over seasons and floods, the pebble chamber cuts a pothole, a drum-shaped cavity, sometimes called a giant's kettle, a marmite du géant, a rock mill, where currents pulse and reverse, walls polish to a matte sheen of rock flour, and helical striae, minute inclined scratches, record the direction and cadence of the rotary flow. The river acts as a lathe, the stones as cutters, time as pressure. If the channel later abandons its bed, the drill work remains high and dry on a terrace, puzzling to anyone who listens only to the present river and not to its former path. A lesser-known detail belongs to sound and touch after rain. When a storm passes and a few centimeters of water remain in the deeper potholes, pebbles clink softly as the last thin eddies keep them turning. The tone is higher in small kettles, lower in large ones, and the pitch drops as water drains. On some walls, a fingertip finds a satin directionality smoother with the spiral than against it, because grains traveled one way more often than the other. Field notes sometimes mention this in a margin. The way stone remembers the hand of water. Facts gather in patterns along old channels. Potholes cluster above constrictions where vortices seed more easily. They occur in belts where the river once accelerated over a lip and slowed again. They repeat on benches that speak of stable levels before incision renewed. In glaciated terrains, subglacial meltwater once roared through pressurized conduits and cut vertical shafts. Moulin potholes that later daylight reveals as neat circles on smoothed bedrock, often perched far above modern streams. Many hold the round grinding stones that made them elliptical boulders, too wide now to exit, that sit like stopped tools in the bottom and show fluted polish around their equators where they turned. Elsewhere, the sea writes the same grammar with a different accent. On marine platforms within the swash zone, backwash eddies collect sand and gravel in small dimples. Waves spin the load, and shore potholes deepen in tide marks that come and go. Where cliffs leak groundwater, Little cataracts deliver a constant fall and drive drill pools beneath them. In tropics, biology adds a careful lance. Rock-boring bivalves, Lithophaga, Pholus, rasp into limestone and leave round mouths visible at low tide. Sea urchins grind sockets to shelter from surge. Boring sponges honeycomb carbonate with galleries. From above, the field reads like a ledger of holes. In section, the origins diverge politely. Perfect cylinders of abrasion here, tapered borings there, ragged galleries elsewhere. Mystery persists in the neat spirals and helices that ring certain pothole walls like tool marks. In some basins, the grooves are unusually regular, their pitch steady from rim to floor, as if one size of stone did most of the work at a constant orbital radius. The river offers explanations: stable vortices, narrow grain size, long occupancy. But the precision can feel excessive. Dating walls directly is hard. The polished surface resists lichenometry and holds no organics for radiocarbon. Cosmogenic nuclide exposure can estimate how long the surrounding bedrock has faced the sky. Buried sands in abandoned kettles sometimes accept optically stimulated luminescence and offer a bracket for when the hole last filled with sediment. Results usually place the work in late glacial or early Holocene freshets, when discharge and sediment supply favored cutting. Yet there remain circles perched high on knolls or arranged along benches where no obvious chute or fall survives, as if a vanished hydrology briefly honed them and left. Another uncertainty belongs to holes aligned like beads across slabs that now lie far from any active water. One academic, uncertain hypothesis links such lines to Kolk scour during catastrophic floods, high-energy vortices forming in standing waves that excavate rock basins and leave spiral flutings as they migrate. The mechanism is accepted in megaflood landscapes, scablands, coulées, spillways below ice dam breaks, but debated at smaller scales on stable crust. In favor are the helical marks and paired scour deposition patterns nearby. Against are lithologies too cohesive for brief events and settings, where there is little other evidence of great flows. The line of holes then becomes a soft argument between energies: patient abrasion at ordinary discharge, or short, violent episodes that left tidy signatures. At the edges of towns with very old walls, regularly spaced circular holes appear on flat limestone panels beside smooth quarries and tool marks. These have another, firmer parentage and belong to the next section. Yet, from a hill, they read like the natural drills of rivers. Distinguishing the two is part art, part metric. Human tubular drilling leaves parallel striae at constant pitch, and often a central core or an annular groove that widens with depth as abrasive slurries flush. Natural potholes tend to widen upward, carry multi-scale scratches, and host lag pebbles or sand. The differences are subtle in weathered rock and vanish where surfaces spall, which is why old stories drift between human and river making. A small, tactile fact lives in some of the deepest kettles. A thin meniscus of rock flour silt, ground to siltia by long turning plasters. A lower wall, to a depth of a handspan. It darkens when wet, dries to a pale skin, and slavs at a touch. Above it, the wall brightens with fewer fines, and above that, quartz veins stand out as white veins in grey, less abraded because they stand proud, and the tools, road, the easier matrix. These textures turn a pothole into a stratigraphy of motion written in millimeters. Other circles look drilled because life wrote them in spirals. In sandstone of estuaries and lagoons, the burrows of worm-like rock borers, Polydora, and crustaceans enlarge over years into tidy round tubes that intersect and confuse the eye. On open coasts, certain periwinkles graze in spirals and incise helical microgrooves in softer rock. Under magnification, the path is precise. These are small scales with large echoes. The motif of circular cutting repeats from the size of a coin to the size of a room, because energy and opportunity push toward the same solutions. Some people have stood by a dry terrace at night, watched a light pause above a line of kettles, and wondered whether visitors prefer clean geometry and hard stone. In the morning, there is nothing new but dew in the holes and a cooled echo where pebbles moved overnight. The suggestion recurs the way rumors do. The work returns to what can be weighed and measured: the pitch of striae, the roundness of sections, the grain in the bottom, the elevation above modern grade. Through it all, the analogy keeps its gentleness. Water, with a small kit of grit and stones, behaves like a patient machine. It spins a cutter, centers it, holds it steady, and lets time deepen the work. The bedrock offers resistance proportional to mineral and cement. The vortex answers with persistence. A pothole is the memory of that negotiation round, because forces radiate; smooth, because friction averages; spiral, because flow is never purely circular, but always climbing or falling a little as it turns. Evening lowers over the bench. The circular mouths darken to small wells of sky. A few still hold their tools. Two stones resting against each other where they once sang. The slab cools. A breeze passes like a file across the rim and moves on. The holes keep their depth and their quiet machines, their echo of work done by fluid and grit in a time when rivers ran harder and higher than they do now, and the ground accepted the cut without the need for any other instrument. On certain benches of granite, on chalk uplands, on basalts that have cooled into plains of dark glass, circles appear that are not made by water, ice, or gas at all. They are quarries quieted by centuries, pits and shallow bowls, whose rims carry the arithmetic of human hands. The edges are too consistent for chance. The walls show marks in sequences. Spoil once stood in small crescents downslope, and has since thinned to low fans that the wind combs level each year. From above, the pattern reads as a field of neat absences, each absence of a size that fits the body and the reach of tools. Accepted processes explain the geometry with a firmness that does not need drama. Stone breaks along planes of weakness, bedding, joints, cooling fractures, and workers long ago learned to persuade those planes to open. In granites and sandstones, lines of shallow, evenly spaced plug and feather holes run along an arc. Iron feathers slipped into each cut, iron plugs driven between them. A pressure distributed itself along the line, and the rock parted with a low report. The spacing repeats like a metronome. In older benches, the wall holds bruises from pounding stones. Harder cobbles swung again and again to peck a channel around a block until it could be undercut and lifted. In softer limestones, a perimeter groove quarrymen call it a channel, circles the destined stone, and wedges work beneath until the bed lets go. The circular pits that remain are artifacts of the unit that was taken. A millstone, a column drum, a grinding table, an ashlar with its corners rounded by weather until the negative becomes a rounder truth than the rectangle that left. A lesser-known detail lives where tool physics meets mineral weathering. On sun-darkened granite, desert varnish grows over centuries into a thin, manganese-rich skin. Where plugs and feathers once bit or hammers once struck, that varnish is absent or newer, and at first light, the pale scars return the sun more quickly than the surrounding rock. A viewer who arrives at dawn can read a quarry by brightness alone, the old work shining faintly, while the untouched surfaces keep their deeper tone. In rain, those same scars hold microfilms of water longer. Beads linger in wedge holes, and for an hour, the pit's circumference glitters, as if the stone remembered not only force, but the small basins that force left behind. Facts collect in patterns that repeat across continents. Where millstones were made, circular negatives lie by the dozens, each with a pilot hole in the middle, where a wooden mandrel once tested balance. On slopes below, broken discs show the learning curve of stone rings that cracked near completion. left in fragments that fit back into holes if a patient hand tries. Where chalk carries flint in dark, glassy seams, ancient miners sank vertical shafts only a few meters wide, then turned outward in low galleries to pry nodules from the soft white. When roofs fell and time filled the shafts, the surface later settled into neat, round depressions, arranged like a honeycomb across an acre. In sandstones near the sea, circles with a lip of waste mark the taking of quernstones and shallow mortars. In andesites, rings with wedge-scarred floors remember column drums intended for walls and colonnades that eroded before the city did. The vocabulary changes. The geometry remains familiar. Mark an arc, free a perimeter, lift from a center. Yet mystery persists in the many pits that keep their roundness but surrender their context. On some plateaus there is no quarry face, only isolated circular extractions 60 or 80 centimeters deep, each separated from the next by several paces, each of a near identical diameter. No road scars reach them, no cairns of spoil remain. Wind has made the ground level around the rims. Lichen now occupies the tool marks. Moss grows in the bottoms where dew collects. What left this pattern millstones never carried. Vats abandoned at the template stage. Blanks cut for wheels that were never fitted. The stones do not answer. Their edges are clean but mute, and the work that began them has lost its name. In other places, the evidence argues across disciplines. A ring of small wedge holes circles a basin in limestone. Broken slag lies nearby. A smear of red soil stains the interior. The facts point to fire setting heating rock with flame and quenching it with water so fracture propagates along a planned line. Flames would have licked the rim in a circle. Water would have carried iron from tools and hearth into the floor. The method is attested widely in pre-industrial quarries, and circular pits suit its physics. Heat moves best into evenly thick walls, and a ring delivers that evenly. But there are basins with the same marks that host no slag, no charcoal in cracks, no reddening beyond what bacteria and clay can explain. The absence may be a matter of time and erosion. It may be a misread. It may be something else entirely. One academic, uncertain hypothesis proposes that a subset of neat, round pits on high benches are not quarries at all, but the ruins of small, lime-burning or ore-roasting kilns whose superstructures have gone. In this account, a circular pit was lined with stone, fed from above and covered. When the wall slumped and the roof collapsed, the hole read, centuries later, like an extraction rather than a construction. In favor, a faint circumferential reddening in some floors, fragments of fused stone at a few sites, and locations near old paths that served valleys rather than cities. Against are the absence of slag and the neatness of wedge marks that look more like stone detached than like stone built into a firebox. The idea belongs in the conversation because the negatives of building and taking can mimic each other after long weather. Another uncertainty belongs to module and measure. Fields of circular pits often show a tight clustering of diameters, the size of a shoulder press or a yoke load, the measure a cart could bear over rough ground. The radius that suits a certain turning wheel. In chalk, flint shafts repeat a human width. In granite, millstone negatives center on sizes that match standard mills within a region. But mixed fields exist, where 2 or 3 diameter families interleave without obvious sequence, as if work came in waves with different standards or different clients, or as if the field was used by separate communities whose tooling differed subtly. Dating by lichen, or by the first colonizing soil, is approximate. Inscriptions, when present at all, are brief and placed where they have spalled away. A quieter, lesser-mentioned detail lives in what returns after people stop. Birds bathe in wedge holes that hold a teacup of rain. Bees occupy dry ones. In shaded pits on north-facing benches, polypody ferns root in fines that collect from the first wind of spring. In winter, Ice rims the holes and writes white ovals inside a grey circle. In summer, lichens tile the walls with slow, stippled colour that speaks of exposure length in decades rather than in days. The pit becomes an instrument that registers water, dust, and light by holding them longer than flat ground can. Some circles confuse origin because technology left overlapping signatures. On 19th century benches, straight rows of star drill holes, cross-tipped chisels turned and struck march along arcs, their profiles triangular in section. On earlier work below, plug and feather marks read as ellipses. On the oldest, pounding bruises cloud the stone like faint constellations. A single pit can therefore carry 3 grammars, none exclusive, and the whole field becomes a palimpsest of methods, rather than a single period's production. The certainty that this is a quarry holds. The precision about which generation made which circle softens. At the soft edge of reports, observers who camp near old benches speak of lights that sit low over a pit and go out, of the sibilant echo a breeze makes when it crosses a ring of empty wedge holes, of the way radio quiet sharpens in shallow bowls just before dawn. The accounts do not enter the measured record. They drift where stories do in places that keep regular shapes and little else. The work returns to what a notebook can hold. Spacing, tool signatures, varnish, lichen length, the relation of pit to joint, the gradient of spoil fans, the absence or presence of burned crust. What remains stable is the physics of taking. A circle minimizes the tool path for a given enclosed area. When the goal is to lift a round object, stresses distribute evenly, forces radiate from a center. Quarries that select circular units, millstones, column drums, mortars therefore leave round negatives with a steadiness that weather cannot erase. The analogy stays gentle. Each pit behaves like a static diaphragm in stone, a once flexing edge that held until pressure from within. Wedges, heat, water, made the boundary move outward by a fraction of a hand. Now, with the force gone, only the rim remains and remembers the direction in which it last yielded. Evening gathers on the benches. The circular floors cool first. A thin breath of denser air pools in them and spills over like water the thickness of a hand. Lichens dim by a shade. A moth slides along the wall where grit and light meet. No machines move, no voices travel, only a low fidelity of wind printed as fine ripples in the dust. The pits keep their symmetry without asking for attention, an industry translated into stillness. The plain accepts them as another set of circles among many, their human origin clear in the pattern of marks, and still, in certain fields, uncertain in purpose, which is a way the land often leaves the past, legible in method, quiet in meaning. Across open flats and low ridges, circles sometimes arrive half-formed, as if the land begins a sentence and then decides to let the rest remain in thought. A crescent trench curves through prairie sod and stops short. A pale arc of salt shines along hardpan and then fades. A low ring wall of stone sweeps across desert varnish and breaks where the ground dips. From above, the incompletions echo one another. Segments that share a radius they never fully close. Chords that never receive their circle. Accepted processes account for many of these partial forms without calling for interruption or intent. Rivers that meander carve oxbow arcs, C-shaped scars of former loops when floods cut new paths and leave behind half-moons of water and then wet meadow. On ancient lake floors, strand lines, beach ridges laid by waves at stable levels, draw long, shallow arcs around the memory of a shore. Later incision removes pieces and leaves crescents that read as unfinished. Around some volcanoes, ring faults bound collapsed calderas. Erosion exposes only segments of those faults as arcuate scarps, the rest buried by younger flows or alluvium. And in dunes, advancing sand overruns part of a circular depression, whether natural or made. And when the dune passes years later, it reveals only an arc, the rest leveled or carried away. Nothing in these asks for a start and stop. The circle's wholeness is made partial by subsequent work. A lesser-known detail shows itself at dawn, where incomplete salt rings lie on clay. The open ends of an arc, where the pale band curves into plain ground, collect dew more readily than the middle span. The slight differences in roughness and thermal inertia at the termini draw a darker comma of moisture that lingers minutes longer than elsewhere, so the arc appears briefly bracketed by two inked commas before the sun levels tone. Field notebooks note this with quiet pleasure. Punctuation afloat on punctuation. Facts gather in surveys that look beneath vegetation. LiDAR on low-flying aircraft strips away the canopy and shows fine relief. Half-ditches under pasture that align with other halves across hedgerows. Arcs of slightly raised ground that trace former embankments. Segments that share a center point far outside the surviving lines. In temperate fields, magnetometry maps contrasts in soil fills darker with organics than surrounding subsoil, and makes a nearly closed ring appear in an image, even when only 2 or 3 segments remain on the ground. Excavation trenches across these arcs often reveal phasing. A ditch begun in one period, silted, recut in another, its fill in bands that stack like a timescale. The sequence shows that what reads today as unfinished can be finished twice, the interruptions belonging to years rather than to intent. Elsewhere, bedrock speaks in arcs as clear as any ditch. In granites and gabbros, ring dikes, circular intrusions that mark the plumbing of ancient calderas outcrop in segments where erosion has planed the country rock. On maps, they appear as curved belts of unfamiliar stone. In the field, the contact is a clean, steep wall on one side and a matching curve far away. The circle is geological and whole, though only a fraction shows. The remainder sleeps beneath soil and forest. Completed in math rather than in view, the accepted process is tight. Caldera collapse opens an annular fracture. Magma exploits it and freezes as a ring. Later time edits the ring into arcs, and the arcs stand on the surface like parentheses around a gap. Mystery persists where human work seems to start and then halt for reasons that do not show. On certain plateaus, low-ring ditches, earthworks a meter deep sweep in arcs and then stop. A few strides short of closing. No causeway entrance interrupts the line. No rock shelf prevents continuation. No settlement debris crowds the gap. In some clusters, 3 or 4 partial rings of identical diameter overlap, each missing different sectors, like attempts at completion by different hands that never coordinated. Radiocarbon in the fills separates the segments by decades or centuries. The arcs share a center no longer occupied by any structure. The uncertainty is not dramatic, it is patient. Why these works begin and pause in so many places remains a soft question answered by circumstance and time. On alluvial fans, arcs of stone cobble berms and low levees curve along contour and end mid-slope. Floods built them, but the neatness of radius suggests a template. In a few, short lines of upright stones set at regular spacing stand at the ends of the arc like markers that never received the rest of the fence. Are these field boundaries erased by later flows, or drift fences for guiding animals, or remnants of enclosures never completed? Artifacts are scarce, soils are thin, wind equalizes clues. The land keeps the geometry and lets the function go. One academic, uncertain hypothesis proposes that certain partial rings in open country were always meant as arcs of sight, not enclosures, deliberate segments tuned to horizon events. In this view, a low embankment or line of stones defines a chord of the sky. Standing at a fixed center, an observer sees the sun or moon rise along the arc's plane at seasonal extremes. A full circle would be redundant. An arc suffices to teach the far geometry. Magnetometer plans from a few sites show repeated radii and azimuths that cluster near solstitial bearings. yet the signal is not universal. In many regions, entrances and gaps in full circles already fix directions. In others, arcs lack consistent orientation. The idea remains careful and local rather than general, a possibility nested among many. Another uncertainty belongs to partial vegetation rings on semi-arid plains. Fairly spaced halos, strong in some years, weaken into C-shapes in others, their open ends oriented downwind. Models suggest that small slope, wind shear over the rim, and asymmetric herbivory can bias a ring into an arc. Long drought freezes the bias into the soil's hydrology, and subsequent rains reinforce the asymmetry. Satellite series show rings that breathe between circle and crescent over decades, a reversible unfinishing that answers to weather more than to singular cause. The visual result mimics abandonment. The mechanism is entirely alive. A lesser-mentioned tactile note lives at arc, ends in stone rings reoccupied by wind. Pebbles there align with their long axes tangent to the curve, a classed imbrication that records prevailing gusts entering through the gap. The imbrication thickens a handspan into the ring and then stops, so a finger can cross from ordered to random in the space of a breath. The pattern adds nothing to origin. It records the arc's openness the way sand records ripples day by day. In glacial forefields, Camaterous arcs, curving ridges laid at the ice margin survive as segments on hillsides where ice once stood. Later streams cut valleys through them till slides masked sections. Farm walls crossed and reused them. The eye reads them now as incomplete rings. The difference is a matter of subtraction, and subtraction is a large part of why incompletion propagates across maps. Processes that favor circles operate, then other processes prefer lines and remove parts. Stories ride the edges of this work. People who travel at night across these flats speak of small lights tracing a portion of a circle, never the whole, then lowering and going out. In morning, the dew seems heavier along that path. The rest of the ring remains dry. The reports sit with the weather that cannot be gauged. Instruments return to slopes measured in tenths of a degree, to grain sizes and fill sequences, to azimuths and radii that a notebook can hold. The analogy remains gentle. An unfinished circle is often a sketch the planet keeps, a draft laid down by water or stone or people, and held at some intermediate step by change. Energy is withdrawn. The line freezes where it was. Later work edits the scene. Roundness is favored where forces radiate. Incompletion is favored where time interrupts. That interruption is neither failure nor message. It is a pause long enough to be mistaken for intent. Evening steadies. On flats where oxbows have dried to meadow crescents, grass darkens a shade sooner in the arc than on the plain. On plateaus, salt arcs dim and then reflect starlight in thin lines. Half rings of stone hold a fraction more cool and gather a slower wind. The incompletions keep their clarity without insisting on wholeness. They belong to the same family as all the circles, but they remind that the family lives on a moving ground that shapes begin, and then seasons, rivers, dunes, frost, or hands move on, leaving arcs to rest in the middle of nowhere, with the quiet authority of something begun and allowed to remain exactly there. Between the circles there is distance, and in that distance a suggestion. Across gravel plains, salt flats, tundra benches, old lava, abandoned terraces, the round marks do not only scatter, some of them seem to fall into lines. A pilgrim of straightness could draw a ruler from one rim to another and to a third, and the eye would nod. From the air, thin alignments appear quiet beads on the flattest strings running for kilometers, bending to the lay of the land, fading and then resuming as if remembering a path that never had a road. An accepted fact gives the first footing. Circles of many kinds, sinkholes, pockmarks, vegetation, halos, salt efflorescences, prefer to nucleate where the subsurface already guides fluids, stresses, or roots. Buried faults and joints focus groundwater and gas. Fractures weaken rock. Dikes and cooling cracks impose repeating weaknesses at regular spacing. Along these structural rails, depressions are likelier to start and likelier to persist. In permafrost, polygons and wedges break the ground on grids. Where wedges intersect, thaw sags recur along lines that the next season remembers. Underwater, pockmarks track fault-controlled seepage like constellations tethered to geology. Alignment, in this sense, is not an intention. It is structure made legible by circular effects. A lesser-known detail shows up before sunrise when wind is still and humidity is high. Cold air drains by imperceptible slopes, chooses the same low microcorridors night after night, and writes dew corridors that gloss the rims it passes. For a few minutes, the line between circles darkens, a chain of darker links on a paler field. By mid-morning, it has gone. Only people who arrive early ever see the thin, wet string that briefly sews the shapes together. The phenomenon explains little and suggests much. Even air prefers paths. Mystery persists in alignments that cross types a salt ring, then a stone ring, then a shallow bowl in clay, each with a different probable origin, yet all falling on a near-perfect bearing. In some basins, the spacing between members repeats to within a body's length. In others, the line points unreasonably far, meeting an outcrop or a vanished shore beyond the practical horizon of walkers who might once have set markers. Statistical treatments soften the certainty. In large, random fields, straight-line coincidences occur more often than intuition allows, and eyes are tuned to applause such order. Still, the cleanest strings remain troublesome, not for what they prove, but for how they refuse dismissal. Facts gather in instruments that quiet the romance without erasing it. Magnetics and electrical resistivity often confirm a hidden control, a fracture swarm, a narrow corridor of altered rock, a paleochannel infilled with coarser sand directly beneath the line. On some desert pavements, micromorphology shows a rim of finer dust along the alignment, evidence that the wind ran truer there for years and shaved the ground to a slightly lower grade. Along a few coastal shelves, repeat sonar finds bubble flares blooming and fading on the same straight strings from season to season, a respiration guided by plumbing that the seafloor hides. These are sober explanations that leave just enough residue of wonder to keep the question tender. Another class of alignments wears human signatures faintly but repeatedly. Fields of ring ditches and low stone circles on step margins, sometimes cue on gentle chords, their gaps echoing a shared module. On chalk downs, nearly lost flint shafts collapse into round pits that fall in rows compatible with efficient underground logistics. In arid uplands, dotted lines of qanat shafts, the subterranean galleries that once ferried water by gravity, draw long bows across slope. In all three, the alignment has engineering inside it. Where survey has not yet run, where spoil has weathered and ceramics are thin, such strings can be misread as natural. Excavation corrects the record one trench at a time, but most strings are never trenched. One academic, uncertain hypothesis proposes that a minority of mixed-type alignments, those that leap across substrate and age, reflect horizon teaching lines, landscape chords placed or selected to cite solstitial or lunar extremes from multiple stations. In this view, people did not make every circle. They chose which natural rings to emphasize with small work, then added new ones where the chord demanded. The idea is careful rather than grand. A village could align a handful of visible rims along a bearing that the sky makes important and use the row as a low instrument. Some sites return azimuths that cluster near expected values. Many do not. The hypothesis remains a local fit with gentle claims. Another uncertain line of thought belongs to catastrophic minutes in quiet centuries. In a few regions, Airbursts or downburst-like blasts have been invoked to explain shallow basins, swept into arcs and lines, the spacing set by coherent vortices rolling along a shock front. Laboratory flumes and wind tunnels can produce rhythmic scour under pulsed flow. Satellite scenes show aligned blowouts on dunes after storms. Applying that to mixed geology is bold. Yet in places where a narrow band holds hundreds of bowls of similar size that refuse karst, ma, or pingo stories, and where delicate rims argue against sustained winds, researchers hold the thought near the door. At the whispering edge of reports, travelers describe lights that idle low over the emptiest places and move along straight paths from circle to circle, pausing, then rising. In the morning, nothing measurable changes but the memory of the line. The speculation that follows is perennial. Observers using the rings as marks, or marks laid by observers. Science files such stories beside weather and returns to bedding, fracture, hydrology, and chance. The alignment remains both ordinary and suggestive, a tone the land plays that the ear has learned to hear. A quieter analogy helps without resolving. In optics, a lens makes a focal line when planes align. In music, overtones align and a tone clarifies. In landscapes, constraints align and circles clarify into strings. None of this requires an author. Pore pressure prefers continuity. Roots follow moisture. Fractures coax fluids. People walk the flattest line. Wind uses the same alleys. Frost remembers polygons. Water finds the same thread twice. Alignment is the budget option for many systems, and circles are the cheapest coins those systems can spend. Lesser-known field notes add their small, exact poetry. On certain salt flats, mirabilite blooms at arc ends more vigorously than midspan. So incomplete rings wear brighter commas in the season's first real cold. On tundra benches, drunken forest trees lean away from thaw circles along a common azimuth, so a row of tilts betrays a row of sags even under snow. On basalt sheets, the morning sulfur floss on fossil vents brightens in the same sequence, along a line as if an unseen valve opened upstream and closed downstream. None of these decide the cause of the strings. All of them let a walker track the alignment by texture and smell, and the order in which small things change. By late light, the lines soften, bearings dissolve into dusk, beads remain, each circle taking back its local physics, salt crystallizing toward white, grass cooling toward dew, feldspar holding heat a little longer than hornblende. The string is a property of distance and angle. The ring is a property of a place. Both can be true, and both can be all a night requires. As wind thins and temperature evens, the long cord turns invisible again, but it waits in stone, water, and soil for the next low sun, the next fog, the next passerby with a ruler in the mind and patience in the step. The last of the light slides away, leaving only the low shapes and the long pauses between them. The circles, near and far, keep their edges without asking for notice. Some hold water that darkens into sky. Some cradle dust that no breeze moves. Some are only a difference in tone, a ring of pale against a deeper ground. Air settles. It drapes itself into hollows, pools in the low places, lifts again in small, invisible tides. Somewhere, a moth folds its wings against a cooled rim. Somewhere else, a thin crust remembers the weight of a vanished pool and waits for another season. The distances between shapes feel slower now, the land stretching in even measures, without the distraction of heat or shadow. Each place rests in its own quietness. Lines lose their bearings. The map becomes a plain surface again, dotted with stillness. Beneath it all, the causes continue, groundwater rising by capillarity, frost working its slow patterns, gases drifting upward, roots and salts trading their balances. But they work without hurry and without the need for light. The same processes that began centuries ago keep their pace tonight and will keep it tomorrow. If there is a pattern, it no longer matters. In this hour, there is only the shared geometry of rest. Edges curved to hold the least strain, forms that have learned to keep their shape with almost no effort. The landscape exhales once, slowly. Above, the first stars open like small wells of their own, each as round and as patient as the hollows below. The air cools, another degree. No sound travels far. Circles on the land and circles in the sky hold to their places, quiet and complete, and the space between them is enough.